An object is placed in front of convex lens at the position of 2f1. Then its image is formed at. So answer is image is formed at 2f2 equals as real and inverted. Now description. If position of object is at infinite, then position of image is f2. If it is beyond 2f2 and at infinite distance, then position of image is between f2 and 2f2. If it is at 2f1, then position of image is at 2f2. If it is between f1 and 2f, then position of image is beyond 2f2. At f1, position of image formed at infinity. Between lens and f1, position of image formed on the same side of lens. When the relative motion between the source and the observer takes place, then sound heard by observer answer is maybe increase or decrease. Now description. Sound waves are longitudinal mechanical waves based on their frequency range. Sound waves are divided into following categories. First one is audible waves. The sound waves which lie in frequency range 20 Hz to 20,000 Hz are called audible waves. The sound waves having frequencies less than 20 Hz are called infrasonic waves. The sound waves having frequencies greater than 20,000 Hz are called ultrasonic waves. Ultrasonic waves are used for sending signals, measuring depth of sea, cleaning clothes and machinery parts. Remaining lamp shoot from chimney of factories and in ultrasonography. Now third one is frequency of sound. The number of complete waves or oscillation produced in 1 second is called frequency of the wave. Its SI units is Hertz, named in honor of Heinrich Rudolf Hertz, who discovered the photoelectric effect. Now fourth one is time period of sound. The time taken by two consecutive compressions or refractions to cross a fixed point is called time period of the wave. It is denoted by T and its SI unit is second. The time period of a wave is reciprocal to of its frequency. Time period is equal to 1 by frequency. Now speed of sound. The distance traveled by a wave in 1 second is called speed of the wave or velocity of the wave. It is represented by V and its SI unit is meter per second. Speed of sound is in a medium is equal to product of frequency and wavelength. Speed of sound is maximum in solids and minimum in gas. When sound goes from one medium to another medium, its speed and wavelength changes, but frequency remains unchanged. Speed of sound remains unchanged by increase or decrease of pressure. Speed of sound increase with increase of temperature of the medium. Speed of sound is more in humid air than in dry air because density of humid air is less than the density of dry air. Echo, the repetition sound is due to reflection of sound waves. Intensity, it is defined as the amount of energy passing normally per unit area per time. Sonar, it stands for sound navigation and ranging. It is used to measure the depth of the sea to locate the enemy submarines and shipwrecks. A decibel is a measure of sound level. Now Doppler's effect. If there is a relative motion between source of sound and observer, the apparent frequency of sound heard by the observer is different from the actual frequency of sound emitted by source. This phenomena is called Doppler's effect. When distance between the source and observer decreases, then apparent frequency increases and vice versa. Force of attraction applied between molecules of same substance is called cohesive force. Now description. Now first one is cohesive force. Force of attraction applied between molecule of same substance is called cohesive force. Adhesive force. While attraction force between molecule of different substance is called adhesive force. Third one is capillarity. The phenomenon of rise or depression of liquids in a capillary tube is called capillarity. A piece of blotting paper soaks ink because of pores of bottling paper serve as capillary tubes. The oil and wick of a lamp rise due to capillary action of threads in the wick. The root hairs of plants draws water from the soil through the capillary action. Now viscosity. It is the property of a liquid by virtue of which an internal frictional force acts between its layer when it is in motion. Now surface tension. The property of liquid by virtue of which it tries to minimize its free surface area is called surface tension. Effect of temperature. Surface tension decreases with rise in temperature and becomes zero at critical temperature. Now, the surface tension of clean water is higher than that of the soap solution. Formation of light shots, spraying results in coldness. Flotation of needle on water, dancing of camphor on water are based on surface tension. Raindrop from the spherical shape due to the surface tension. When kerosene oil is sprinkled on water, the surface tension decreases, due to which excess of mosquitoes floating on the surface of water die due to sinking. Now fifth question. The substances which are feebly magnetized in opposite direction of magnetic field are called. The answer is ferromagnetic. Now description. What is magnet? Magnet is a piece of iron or other materials that can attract iron containing object and points north to south when suspended. When a magnet is freely suspended, its one pole always directs towards north. This pole is called north pole. The other pole is called south pole. Similar poles attract each other and dissimilar poles attract each other. Now what is electromagnet? A current carrying coil containing a soft iron core is called electromagnet, which is utilized in electric bell, telegraph, receiver, telephone diaphragm, transformer and dynamo. Now magnetic substances. Normally every substance shows some magnetic behavior in a strong magnetic field. On this basis, magnetic substances are classified into three types. These substances which are feebly magnetized in opposite direction of magnetic field when placed in strong magnetic field are called diamagnetic substance like gold, silver, zinc, copper, mercury, water, alcohol, air, hydrogen, bismuth, antimony, quartz, etc. Those substances which are strongly magnetized in direction of magnetic field when placed in it are ferromagnetic substance. Example iron, nickel, cobalt. Now those substances which are feebly magnetized in direction of magnetic field when placed in a strong magnetic field are called paramagnetic substance. For example, aluminium, platinum, chromium, manganese, solution of salt of iron, nickel and oxygen. Now fourth question. For total internal reflection, angle of incidence should be. Answer is greater than critical angle and equal to critical angle. Now description. Dispersion of light. When a ray of white light is passed through a prism, it gets split into constituent colors. This phenomenon is called dispersion of light. The different colors appeared in the spectrum are of the following order. First one is violet, indigo, blue, green, yellow, orange, and red. This is known as VIBGYOR. Rainbow is formed due to dispersion of light by water droplets. Wavelength of red color is maximum and for violet color is minimum. Red, green and blue are primary colors while green and magenta, blue and yellow, red and cyan are complementary colors. When yellow and blue colors are mixed, then green color is produced. Now scattering of light. When light passes through a medium in which particles are suspended whose size are of order of wavelength of light, the light on striking these particles deviated in different directions. Scattering of light is maximum in case of violet colors and minimum in case of red colors of light. Blue color of sky is due to scattering of violet light. Brilliant red color of rising and setting of sun is due to scattering of light. Now total internal reflection. If light is traveling from denser medium to rarer medium and the angle of incidence is more than the critical angle, then light is reflected back into denser medium. This phenomenon is called total internal reflection. Sparkling of diamond, mirage and looming, shining of air bubbles in water, and optical fibers are examples of total internal reflection. The angle of incidence in denser medium, for which the angle of refraction in rarer medium becomes 90 degree, is called critical angle. Now optical fiber. It is used in TIR, used for telecommunication and various medical purposes like endoscopy. Atom bomb is based on. Answer is nuclear fission. First one is what is nuclear fission? The nuclear reaction in which a heavy nucleus is split into two nuclei of nearly equal mass is nuclear fission. Atom bomb is based on nuclear fission. Uranium 235 and Pu 239 are used as fissionable material. Nuclear fission was first demonstrated by Hattin and Fritz Strassmann. Now nuclear fusion. When two or more light nuclei combine together to form heavy nucleus is called nuclear fusion. For nuclear fusion, a temperature of the order of 10 to the power 8 Kelvin is required. Hydrogen bomb was made by American scientists in 1952. This is based on nuclear fusion. It is 1000 times more powerful than atom bomb. Now nuclear reactor and atomic pile. Nuclear reactor is an arrangement in which controlled nuclear fission takes place. First nuclear reactor was established in Chicago University under the supervision of Professor Enrico Fermi. Now uses of nuclear reactor to produce electrical energy from the energy released during fission. Second, to produce different isotopes which can be used in medical, physical and agriculture science. There are several components of nuclear reactor which are as follows. First one is fissionable fuel. Uranium 235 and uranium 239 is used. Second one, moderator. Moderator decreases the energy of neutrons so that they can be further used for fission reaction. Heavy water and graphite are used as moderator. Now control rod. Rods of cadmium or boron are used to absorb excess neutron produced in fission of uranium nucleus. so that chain reaction continues to be controlled. Now coolant. A large amount of heat is produced during fission. Coolant absorbs that heat and prevents excessive rise in temperature. The coolant may be water, heavy water or gas like helium or carbon dioxide. Radioactivity. Radioactivity was discovered by Henry Becquerel, Madame Curie and Pierre Curie, for which they jointly won Nobel Prize. The nucleus having protons 83 or more are unstable. They emit alpha, beta, gamma particles and become stable. The elements of such nucleus are called radioactive elements, and the phenomenon of emission of alpha, beta, and gamma particle is called radioactivity. Now, third is Robert Pierre and his wife Madame Curie discovered a new radioactive element, radium. The end products of all natural radioactive elements after emission of radioactive rays is lead. With emission of an alpha particle, atomic number is decreased by 2 and mass number is decreased by 4. With emission of beta particle, atomic number is increased by 1 and mass number does not change. Alpha, beta and gamma rays affects the photographic plate by blackening the films. What is measured by hydrophone? Answer is it measures sound underwater. Now description. Hygrometer, it is used for humidity in air. It is used Periscope is used for measuring level of sea. Voltmeter is used for measurement of voltage. Now important scientific instrument. Altimeter, it measures altitudes and is used in aircrafts. Ammeter, it measures strength of electric current. Audiometer, it measures intensity of sound. Barometer, it measures atmospheric pressure. Binocular, it is used to view distant objects. Cardiogram, it traces movements of the heart recorded on a cardiograph. Dynamo, it converts mechanical energy into electrical energy. Dynamometer, it measures electric power. Electrometer, it measures electricity. Fathometer, it measures the depth of the ocean. Hydrometer, it measures the specific gravity of liquids. Hydrophone, it measures the sound underwater. Lactometer, it, me- it determines the purity of milk. Manometer, it measures the pressure of gases. Microphone, it converts the sound wave into electrical vibrations and to magnify the sound. Microscope, it is used to obtain magnified view of small objects. Odometer, an instrument by which the distance covered by wheeled vehicle is measured. Now periscope, it is used to view objects above sea level. Radar, it is used to detecting and direction range of an approaching plane by means of radio microwaves. Radiometer, it measures the emission of radiant energy. Spectrometer, it is an instrument for measuring the energy distribution of particular type of radiation. Stethoscope, an instrument which is used by the doctors to hear and analyze heart and lung sounds. Tachometer, an instrument used in measuring speeds of aeroplane and motorboats. Telescope, it views distant object in space. When an object is placed at first focus of convex lens, then its image is formed at infinity. Now formation of image by convex lens for different position of object at infinity. Second is beyond 2f1. Third one is at 2f1, between f1 and 2f. Fifth one at f1. Sixth one between lens and f1. at infinite. When position of object is infinite, then size of image is extremely diminished. When it is between 2f1 and infinite distance, then size of image is small size. At 2f1, the image of same size between f1 and 2f is magnified. At f1, highly magnified. Between lens and f1, size of image is magnified. An object is placed between the focus and center of curvature on the principal axis of a concave mirror, then size of nature of image will be large and real. Now, description. At infinity, the position of image is at focus or in focal plane beyond the center of curvature, but at the infinite distance, then position of image is between the focus and the center of curvature. If position of object is at the center of curvature, then position of image is at the center of curvature. If position of object is between focus and the center of curvature, then position of image is beyond the center of curvature. If position of object is at the focus, then position of image is at infinity. If position of object is between the pole and focus, then position of image is behind the mirror.